Hello again, it's Cliff here from Down Under. In this video I want to talk about considering purchasing a tool changer versus multiple part work offset type production. Some of you will probably notice from my previous videos that I have two 1100s, and I bought just the base machine, just the $8,000 or $9,000 price of the base machine and the essential components, and then I built my own stand and enclosure, so I've got two machines running for a very low price, not much more than the price of a completely kitted out machine with a tool changer. And my theory was that I could run the two machines back to back, moving backwards and forwards between them, doing the quality control, changing the parts and so on, probably more efficiently or more productively than having one machine fully kitted out with a tool changer. Well, that's been my take on it anyway, and it's suited the type of work I've been doing to date. But in this video I want to demonstrate graphically doing multiple part production for those of you who have not yet done that. I'll go through it at a sort of beginner's level, how to set up more than one part on the table, and so because all things being equal, multiple part production with multiple offsets is as productive as a tool changer with one part. All things being equal, 3 tools versus 3 parts and so on. One of the reasons why I haven't purchased a tool changer is I've read a few threads and comments and had a couple of emails from owners of tool changers who have claimed that they're unreliable, and I'm sure most people get their tool changers running reliably and don't have any problems, but that sort of adds to my concern a little bit. And another thing that worries me is that I'm doing quite a lot of precision work and for my mold making work, tool and die making work, and I also do production runs of parts for the aeronautical industry and medical industry, and they need to be really high precision. And I find that with the TTS system, it needs to be spotlessly clean around the diameter and the contact flange and the bottom of the spindle nose. And when I'm doing tool changes on highly critical parts that need high accuracy, I usually wipe the bottom of the spindle nose and the flange, because I've noticed that if there's a little speck of dirt or metal on that surface, it can throw the tool slightly off, and you can trace where the error in the part is down to that. And I wonder with a tool changer whether I'm going to get as accurate a homing of the tool on its flange and diameter each time. So for both accuracy concerns and reliability concerns, I have stayed away from a tool changer. But I know there are many people that have tool changers and are 100% happy with them. So this is not a negative for Tormach Toolchangers. It's just talking about my concerns for the type of work I'm doing anyway. So while I've broached that subject, if you have a tool changer and you're running it reliably, and you're running it all day long, day after day, and you're not having any accuracy or reliability issues, please put a comment in the thread underneath this video, because I might still consider adding tool changes to my machines if I can see that it's going to be accurate and reliable. And likewise, if you purchase a tool changer and you are not completely confident that it's 100% reliable, please post that in the thread underneath as well, because I'd really like to get several tool changer owners' points of view on this. Would be really helpful to my decision. And also there's probably others watching this video that are thinking about buying a tool changer, and you can look down in the comments and see, well, the majority of people that have watched this video have tool changers and they are 100% happy with them. So that gives you and me the confidence to go ahead and consider one. Alright, so I'll get on with this video now. I'm just going to go on now showing basically how we can set up multiple work offsets for beginners on this subject, and cover 1 or 2 tips along the way. Cheers. So when you're posting a comment about something you've purchased, do you notice it's a human characteristic to try and justify what you've done, what you've purchased? You want to feel that you've made the right decision, and you've bought a product and you want to announce that it was the right thing to do, and it makes you feel better about yourself. It's a human tendency to do that. It's very hard to be objective and say, well, I spent $8,000 on a tool changer and the pneumatic system and a compressor and a power drawbar, and yeah, I've had one or two problems with it, but oh, I wouldn't be without it. You know, it's human nature to justify the decision we've made. So try and be objective about these things, and I'm speaking to myself as well, because human nature really does get in the way of scientific objectivity. Cheers. I've just finished a big run of parts now, running 3 parts at a time, and the machine has run by itself for long enough for me to go away and do a lot of useful work. I've been busy over the last couple of days doing other productive work, and so I think it's been relatively efficient. One of the things is to have a little block set up with your tool numbers, and to have tool shapes and tool planning that allow one tool to do more than one operation. That way you're minimizing the number of tool changes, and by having tool numbers and shapes for each hole, you can swap out the tool even towards the end of the day when you're getting tired, and you're much less likely to make a mistake. So you can look over on your control software where just before you push cycle start, you know, with only quarter of a brain towards the end of the day, insert T24, yeah, I've got a tool in there. Look over here, yeah, there's a gap there, that should be tool 24, correct, hit go, you know, and you can just sort of do that quick double check as you're running and make yourself as a human being a much more reliable tool changer. Multiple parts and multiple work offsets can be as efficient or as big an increase in productivity as having a tool changer, all things being equal. Of course, it's not always the case, but you need to think about your particular situation carefully. Obviously, multiple parts and work offsets running with a program is going to be a lot more reliable. There's a lot less things to go wrong than a tool changer changing tools with an air pneumatic system and all the potentials for a disaster. And one of the most important things about productivity is that it's reliable, so that you can safely trust it to run unattended and go away and do something else. So you've got to think carefully as to whether the cost of a tool changer and the operating system for a tool changer is justified. It's a big cost. Of course, you've got to remember, we're not talking about mass production here. We're not talking about lights out, fully automatic production. We're talking about low volume batch production. Lights out, fully automated production, you need robots, you need conveyors for parts, you need conveyors for chips, and automated quality control measuring system to really produce thousands of precision parts automatically. But if we're not talking that, we're talking batch production, we're talking scores or 100 or 200 parts. And you're going to have a lot of hands-on. Even if you've got a tool changer, you're going to be loading parts, clearing swath, checking, quality control, measuring, manually fettling, and so on. And so you're going to be hovering around the machine a fair amount of time anyway. So all you really, this is my point that I think we need to think about carefully. If you can get your machine to run for long enough to allow you to go away and do something else, perhaps run another machine automatically at the same time, semi-automatically at the same time, your increase in productivity is doubled. And for low to medium volume batch production, that can often be a more cost-effective way to go. Okay, going into work offsets for newbies or beginners. Say you've got a job and you're making 1 or 2 parts, and you've set it up in your vise or your chuck, and you're manually changing a few cutters, and you're running the part one at a time. And that's fine, you know, you're only making 1 or 2 parts. But then the customer comes along and says, I want to make 10 parts. And you think, oh, okay, well, it's going to be a bit boring. It'll take me a few hours, because I have to put in 4 different tools. But okay, that's okay, I'll just do it, you know, a few hours work. And then next month your customer says, I actually want you to make me 200 parts. And you think, oh God, that's going to take days, you know. Well, you start thinking, do I need a tool changer? Well, of course, you've got another option. Instead of having an automatic tool changer, you can have multi-stations for your parts and put in multiple parts so that the program runs automatically from one part to the next and that is, all things being equal, just as efficient and just as big a time saving as having a tool changer. All things being equal, if you've got 3 parts set up, that's the same as having 1 part set up and a tool changer with 3 tools in it. So obviously there's all sorts of variables here, but all things being equal, multiple parts is the same as having multiple tools automatically changing. So it's a very low cost way to increase your productivity, to increase the automation of the work you're doing by having multiple parts and multiple work offsets. Now, this is just an introduction to the subject, and I'll just take you through it in very simple practical terms so that if you're new to this, you can get your head around what it actually is. So again, in really simple terms, and I know this would have been helpful to me when I was beginning to learn about CNC. I found this all very confusing, and I'm sure there's newbies out there that are wondering about this. So in simple terms, a work offset is information that the control software needs to know where the spindle center line is relative to your job, your work, your part. So let's call this, you're just making 1 part, and the work position, we'll call it G54. It's just a number. It could be number 1, but we're going to call it G54. And we're going to call the center line of the spindle and the tip of the cutter a setting tool number 99. Tool number 99. That's the number for a probe, and it represents the center line of the spindle and a distance down from the spindle. So we have a tool number 99 and a work G54. That's just, in simple terms, you're only making 1 part and your station for the work is G54. Your spindle center line is tool number 99, and that's really easy. The software knows those distances and does the maths. But okay, so you decide that you want to make 100 of these parts now, and you're going to have multiple stations. So you set up another chuck or another vise, and another chuck and another vise, and you're going to make 3 at a time. Well, how do we actually, in practical terms, how do we get the machine to make 3 parts? Well, what we do is we describe the 3 different positions. This one's G54. Let's call the next vise or chuck G55. Let's call the next vise or chuck G56. And the tool center line, the spindle center line, setting tool number 99 in this case, that remains the same. So again, keeping it really simple. So if you've only ever made 1 part at a time in the past, you probably have unknowingly been machining it to the work offset of G54. If you look here at the bottom, you'll see a status line of G code. Well, G54 is the default position. Call it position 1, G54. But let's say you've now decided for the first time you're going to set up a second and a third part. how do we change the software's understanding that we're doing that? Well, we just enter into here, into your manual data input, G55. And when we press enter, just watch these DROs change. Now we're in a different coordinate system, a different work offset system. We're now in G55. You can see it there confirming what you've done in the status. So all we need to do now is index over to that position and set it with a hammer, with a pointer, with a probe. I use a probe because it's quick and easy. So let's do that now. Okay, so we've set our control software offset to G55, or position 2, or station 2, or station G55. Let's come down now with our probe into the middle of our setting ring, and if we go to the probe page, this is a quick and easy way to set the center, find the center and set the work origin. Now you can do the same thing with a hammer or with a pointer or with a wobbler, but that's just a quick way to do it. So now the software knows where X, Y, 0 is for G55, for the second position, the second station. And we go on and repeat the same thing for the third station and so on. So now the software knows where those different positions or stations or vice or chuck homes are. And while we're still on the G55 work offset, we'll set the Z. We'll go to the probe page, probe Z, set work origin. Now it knows where the Z is for G55. So we do the same for G56 or however many stations we have, and those positions are remembered in the software. Okay, let's go over to the control software now and see if we can explain the other side of it, about the G code. Alright, so this is our original program showing one part in the graphic display. There's our tool path. Let's just say we've got one tool and the original position is G54. And we can see down there in the status it's G54. Alright, but now we've got three different parts, and two of them are in new positions, G55 and G56. How do we do that? Well, the easiest way to understand it is if we edit the software. Let's just say we go into edit and we copy and paste that little bit of G code over and over twice. So now we've got three copies of the G code end on end. If we ran that bit of G code, the tool would just rerun over the part 3 times in the same position. But if we edit the G position, the G54 position, at the top of the code it's G54, that runs the first part. When we come to the second copy, or the first copy, the second lot of code, we change it to G55, and then the third bit of code that we've copied and pasted the second time, that's the third bit of code, we enter G56. Suddenly we have 3 different bits of code with different numbers. And on the display it will look like this, graphically showing the different position. Now you can see the little XY coordinate system over G54. Let's enter G55. Look at the little XY shift over to this position. That's our second position. G56, enter it, it'll shift over to this position. So now we have a bit of code that's much more sophisticated. It'll run the part in 3 different positions. Now this is real basic fundamental stuff. I'm not going into the details of multiple tools or using subroutines. There's more elegant solutions to the problem, but I'm just graphically displaying it in this way so you understand the concept of it. Okay, so as explained, I want to keep this really simple and basic. As far as producing the code that instructs the machine to go to the different stations, to the different work offsets, to the different work positions, I want to show it really graphically. A more elegant solution is to use subroutines in your code, and you can look at YouTube videos on how to do that. I actually produced a really basic one back in 2015, but I'm sure there is much better YouTube videos on the subject. But I just want to use the copy paste idea just to make it really graphic. So we've got a very simple bit of code. If you produce it with your conversational, you'll get a very simple bit of code. And if you go to File and go to Edit Code, you get it up here in a text editable form. Now if you look in here, the default position is G54, set work offset, and that's at the top of most simple bits of code for a single part program. So all you need to do is to copy and paste that end on end. So you take that down to about that position. You want to leave the end program part out, and then just copy and paste it, and end on end. Do that 3 times if you've got 3 parts. And where your G54 is, it'll run through the first part, come to the second copy, rather the first copy, the second set of code. You just enter in there G55, and then it'll run through that until you get to the 3rd time, and you put in G56 and so on. So basically you've got end-on-end code, and if you just save that and call it you know, the name of your part with 3 work offsets, so you can clearly identify it in the future. So that's it in a very graphic, simple way. Well, thanks for watching that through. I'd really appreciate your feedback. Please put a comment below if you have a tool changer and you're finding it 100% reliable, or you're not confident with it. I'd really like to know that. Alright, thanks, cheers.